All right, here we go. This is number 14 and 15 from homework number 3, graphing parabolas. And a lot of people are struggling with this, so I thought I'd make a video. I'm not going to go over it in class just because we have a lot to do. So it says a crew chief uses the equation below to model the distance a race car has traveled during a race down a straight track. In the model, the distance is y, so the distance that the car has gone is y. And it is a function of x, the number of seconds after the start of the race. So x is your time, distance is your y, and gives you the equation y equals 14x squared, and wants you to graph the parabola. So first and foremost, we know that the vertex is at 0, 0. For this graph, your graph might be different. So let's say, for example, you had y equals 16x squared plus 64. I don't know what the numbers are going to be. Your vertex would be at 0, 64 if that was your equation. Okay, so you have to shift the vertex according to whatever question you have. Okay. Now, we also know that A is equal to 14. So that means from the vertex we're going to go up 14, and then we're going to go up 14 times 4, which is 56. Okay, so this will go up 14, this will go up 56. So this should be 1, 14, and 2, 56. Amazing. So now let's look at our graph. Looks like we are able to put our vertex 2, 56. Don't forget, parabolas are symmetrical. Whoops. Okay. Now we're not able to put 1, 14 on here, so you're going to have to use this graph a point tool. Okay. And we go here, we click 1, 14. And we add another point, and we need to do -1, 14 to make it symmetrical. And there's our points. Click plot graph, and there's our graph. I'm gonna have to erase this because I need to move on to the second half of the question. I think most people are confused about this part of the question right down here. Okay, so I'm going to make this a little smaller. Here we go. Okay, it says the length of the race is 224 meters. So if we look at our graph, that's right here. Right there is when the race stops. Okay, so the race stops 224 meters. That's for this function. It produces an accurate distance y from 0 to 224. So that's the length of the race. It wants us to fill in the blanks below to write the inequality of values for x that compare to these y values. So if we're looking here for the race, we would start at 0. Okay, and then we would travel all the way to 4 seconds, and that's the end of the race. So this needs to be 0 to 4. Okay. Then it gives you an option. It says this description is the portion of the domain or it's the portion of the range. So this will be the portion of the domain. Domain are x values and range are y values. So this is domain. Awesome. Now it also asks when the value of x is, or when the value of y is 56. What is x? We already know that. Okay. It would be when x is 2. Okay, 2, 56. And that is the time in seconds the race car needs to travel 56 meters. Okay, let's check it. Boom, green check mark, always feels good. Let me look at number 15. Okay, this one right here gives us an equation for the height of a cannonball shot from ground level. So right here, if you look, we're at 96x minus 16x squared. This right here, we'll need to do standard form to graph it. So we have y equals 96x minus 16x squared. So we will do negative b over 2a, which is negative 96 over 2 times negative 16, which is negative 96 over negative 32, which is equal to, that's equal to 3, believe it or not. Okay, so that's equal to 3. We plug that back into the equation. Oh boy, this is going to be a big one. 9 times negative 16 would be 144. Negative 144. And here we have 96 times 3. Oh boy. Okay, we know 100 times 3 is 300. Subtract 12 from that. 288. Remember, these are always double, so that works. And so this will be 144 for the y value. So our vertex will be 3, 144. There we go. And then we need to go with an a value of negative 16. Okay, which means we need to go down 16 and then down 64, which means our coordinates will be 4, oh boy, what's 144 minus 16? 144 minus 16. Oh golly, oh golly. 144 minus 16. 128. And we'll also have 5, down 64. I'm not doing that one in my head. No way. Okay, so there's our 3 coordinates. We need to plot them with your plot a point tool. Okay, so you will do 4 coordinates. Okay, you need 4. We need 5. We will also need 2. And 1. Okay. So this 4 right here will be 128. Just take this with me. This 5 right here will be 80. This 2 will be 128 because they are symmetrical with each other, because they are on either side of the 3, which the 3 is our vertex. There it is. All right, so there's our parabola. As you can see right here, it goes through 0, 0. All right, and then you'd have to answer the questions about the domain and the range and talk about the x values and the y values. It's the same exact process as we did on number 14, but I'm out of time. If you still have questions about these, just ask me during class or intervention. Good luck.